Thanks for coming, everyone. Tonight, I'm going to talk about Sitecore with Solr Cloud, which it's something I've been working on a lot over the past several months. Kind of accumulated a lot of knowledge that I wanted to share, with the Sitecore community, because a lot of this stuff wasn't easy to figure out. I was reading blog posts, reading wikis and documentation and futzing around with stuff and opening support tickets and generally just, sometimes crying, sometimes jumping for joy. And, it was an interesting experience. So the purpose of this talk tonight is to familiarize you, first of all, with what Solr and Solr Cloud are. You may not even know what those things are, so I'm going to spend a lot of time talking about that. If you're familiar with Sitecore, you know that they have the search provider model, and Solr is one of the things that Sitecore actually officially supports as an alternative. We've seen. Okay. We're going to talk about some of the advantages and disadvantages of using Solr as your search provider. So just up front, I want to say there's a lot of information. I'm not going to get into. I'm going to go over a lot of stuff at a high level, but I understand that it's going to be a lot to absorb. But hopefully, if at some point down the road you're sitting down, you're tasked with implementing Sitecore with Solr or Solr Cloud yourself, you'll think back to this talk, and it'll get you off to a pretty fast start. So just a bit about me, Chris Sulham, principal developer here at Velir. Been working with Sitecore for about 7 years. I've taken Sitecore to production with Solr before. We're taking another project to production with Solr Cloud in the next couple of weeks. But that thing's pretty much buttoned up at this point, so I feel confident enough to talk about it right now. I'm also a superhero enthusiast. That's from Halloween this past weekend. That's me and my son, saving the world from too much candy. Took it off your hands. So I just wanted to start with an overview of Solr and Solr Cloud, just to, so you understand what this thing is we're talking about here. And it's important to understand what they are and how they work at a high level if you're going to consider using it as your search provider. So what is Solr? Here's the textbook definition off the Apache website. It's an open source enterprise search platform powered by Lucene. Lucene's the same thing that Sitecore ships with as the search provider, so you may be familiar with it already. It's pretty fast, it's also open source, and it is the foundation of Solr. That's what drives the search engine. So who uses Solr? You may have heard of some of these organizations. They just came up on a quick Google search, so they seem like a good example. So if places like Netflix and NASA and Apple have confidence in Solr, you should too. It's pretty well established. So why would you use Solr with Sitecore? One of the pieces of feedback I got, and I demoed this yesterday to some folks at Velir, is more graphics, more memes. You guys might be excited. Someone might be excited about Follow coming up next week, so this seemed appropriate. So why would you use Solr as your search provider? So the first thing that drives a lot of people into looking towards Solr is the fact that they have to support multilingual search. And they demo their search to a client, and they actually understand the language that's not English, and you, the developer, don't. And they say, this relevancy is awful, or this syntax is all wrong. These search results are really not good. So you start looking around and you say, hey, this thing Solr, which Sitecore offers a support package for, it's got some pretty good support for multilingual. So it does. So out of the box, when you set up Solr with Sitecore, you're going to get support for most of the languages that Sitecore ships with, in the language config file, with a few notable exceptions. But they're pretty much all in there. And if they're not in there, you can add them. The community's out there. People have figured this out. So that includes things like stemming and stop words. If you're familiar with search, you understand what those things. You probably understand what those things are. Language analyzers. The grammar in English is different from the grammar in Japanese, right? So you can't exactly search on keywords the same way. It's slightly different. And when you set up Solr, most of these things are pre-configured, so it's just going to work. Centralized indexing. This becomes a bigger deal as you start to, scale out your Sitecore solution. So most of us, when we go to production, we have redundant content delivery servers, right? You have 2 content delivery servers, and if you're running Lucene, you've got a copy of all your indexes on each one of those servers, right? And you may have noticed when you run a publish that the CPUs on those servers spike up to like 99, 100% as it's crunching all those indexing operations, and that's happening on both machines. And not to disparage the wonderful code of Sitecore, but sometimes those indexes fall out of sync. It happens. And it's a logistical nightmare because you're not running regression tests on your entire search index, but the second they fall out of sync, somebody finds out and it's a P1, right? So wouldn't it be great if every front end was returning the same search result? Well, centralized indexing will give you that. And it'll also give you a performance boost because you're offloading all of those indexing operations to a single server. So you can run a publish and it's not going to, make your request time shoot out because your front ends are indexing 10,000, 100,000 documents. So we also, as part of this project we're rolling out on Solr Cloud, we did do some performance testing. We had our release. We had a branch on Lucene, we had a branch on Solr. We deployed it to our load test environment, ran the exact same scenarios on each one to kind of see what would happen. And the Solr provider showed us that we can handle 50% more concurrent users. So it went from like 400 concurrent users to something like 750. So it was actually a little more than 50% more. So it was pretty good. Because of the way Solr works, we'll get into that in a bit, because of the way Solr works, it operates over HTTP, so the queries themselves take a little longer to run, but because you're not running them on the server's free to do more stuff, fulfill more page requests, and those resources are freed up. And finally, scalability. You think about this in a couple ways, but the fact that Solr Cloud is meant to be like an enterprise-level implementation of search, it scales really well. You can have 3 servers, you can have 50 servers all working together, and depending on your search load, it's going to work. So imagine having 50 front ends all serving Lucene requests and all having to crawl, these same indexes every time you publish. It's just not a good scalability model. And you can also start to think about distributing this thing globally. You can have Solr Cloud clusters strategically placed in your data centers, and it's just a much more scalable search solution. So I was talking about Solr, and this talk is actually about Solr Cloud. So what is Solr Cloud? Again, here's the textbook definition from Apache. Solr Cloud is the name for a cluster of Solr servers that combines fault tolerance and high availability. In other words, it's just a bunch of Solr servers working together to fulfill indexing operations. So Solr Cloud provides for you a central configuration for your entire cluster. So what this means is that your configuration for your indexes is managed in one place rather than on each Solr server. So if you've ever used Solr before as your search provider, you may know that you have your index folders as part of your core, right? And if you have multiple cores, you're copying that configuration to each one for each Sitecore core. And again, that's not the most scalable model. So with Solr Cloud, you get centralized configuration. So you can update it once and it gets pushed out to all of the collections that are using it. We have automatic load balancing and failover for queries, and I may, if we have time, I may get into a demo later. I can take one of the nodes out of the Solr cluster and it just keeps chugging along. It automatically it recognizes what's happened, it accounts for it, it fails over to the correct nodes. If you take the leader out, it elects a new leader. This all happens transparently, and it's all really solid. You bring the node back online, it catches itself up and starts fulfilling requests again. It's all just magic. It's great. And Zookeeper integration for cluster coordination and configuration. And what this means is all that great stuff I just talked about, it's done by this tool, Zookeeper. So what is Zookeeper? That's the next question. Again, the textbook definition from Apache. This is another Apache open source product. A centralized service for maintaining configuration, information naming, and providing distributed synchronization and providing group services. That sounds like a lot of stuff. Zookeeper's role in Solr Cloud is essentially just organizing stuff, keeping tabs on everything, and sort of acting as the director. And this is a really cool logo they have for Zookeeper. It's this little cartoon guy. Looks like he was thrown together in like 2 minutes. So this graphic I blatantly stole from IBM. IBM is one of the main contributors to the Solr project and to Zookeeper. So they have a whole team dedicated to contributing to the Solr repo and sort of adding features to it, and watching the tickets in Jira and responding to them. So they're not technically the owners, but they're one of the main contributors. So I stole this graphic from them. This isn't necessarily Solr Cloud, but it kind of explains to you what Zookeeper is, because this was really complicated for me to understand. Like, what's the dividing line between Solr and Zookeeper? Like, who does what? Why do we even need this Zookeeper thing? What does it do? So if you think about these servers here as your Solr nodes, Zookeeper kind of encompasses them and sort of, protects them from each other. It handles, if there's a conflict, if two of these nodes disagree with each other, they go to Zookeeper and say, hey, what should we do? How do we resolve this? And Zookeeper tells them how to do it. Zookeeper is also in charge of the configuration. So I mentioned before that we have centralized configuration. Well, that goes into the Zookeeper. Zookeeper is the one in charge of the configuration. So when you push a config set for your cloud, you push it into Zookeeper, it gets stored there. That's where you pull it from. That's where Solr reads it from. It's in charge of leader election. So I mentioned that it's in charge of handling conflicts. So what Zookeeper does is it picks one of the Solr nodes to be the leader for a collection, and that leader is in charge of taking the requests and distributing them out to the other Solr nodes. And if that leader ever becomes unavailable, Zookeeper will elect a new one. It's also in charge of collection synchronization. So essentially what that means, it makes sure that the individual cores in the collection are up to date and synchronized. So if one goes offline, comes back online, it goes to Zookeeper to figure out where it is in the history, like how much have I missed, right? If for some reason it's not in agreement with the other nodes, Zookeeper is the one that's going to figure that out. It's not the other Solr nodes. So another important point is that, so we have Zookeeper, we have Solr, and then we have Solr Cloud. If Solr Cloud's a bunch of Solr servers working together, a bunch of Zookeeper servers working together is called an ensemble. So you need a Zookeeper ensemble for high availability. That's another requirement. You don't want Zookeeper to be your point of failure. If you have 3 Solr servers and only 1 Zookeeper, you don't really have high availability. So that's great. I mean, that's what Solr Cloud, Zookeeper, that covers that. So let's talk about connecting Sitecore to Solr Cloud, what that might look like. So what I've got here is sort of kind of your minimum architecture to run Sitecore with Solr Cloud. I'm kind of assuming that if you're looking at centralized indexing, you've got a content entry environment or a CM environment. You've got at least 2 content delivery environments in your architecture. So here we have our Solr Cloud represented by this sweet cloud graphic with 3 machines in it. The reason we have 3 machines in our Solr Cloud is that is the bare minimum for a functional Solr Cloud. And the reason for that is you have to understand how Zookeeper resolves conflicts. So when Zookeeper wants to resolve a conflict, it has to reach what's called a quorum. And the way it does that is it takes the number of nodes in the cluster divided by 2 plus 1. So if you think you've got 3 nodes, 3 divided by 2 would be 1, because it rounds down, and then you add 1 to get 2. So you have to have at least 2 nodes in agreement in order for the cloud to be functional. If I were to add another server, that server would need 3 nodes in agreement, because 4 divided by 2 is 2 plus 1 is 3. So adding another server to this really doesn't help availability. You can still only use one and have the cloud lose one and have the cloud stay online. But this is just for an understanding on how this sort of works. So bare minimum for Solr Cloud is 3 servers. You may have, if you've researched this on your own, you may have seen that, not understood why. Well, this is why. You'll see here we have a load balancer. And that's sort of a particular piece of this architecture you need specifically for Sitecore. Solr Cloud supports a querying layer that is a load balanced query. Unfortunately, the current version of Solr.net hasn't implemented support for that. So in order to make sure your requests are kind of going to the available nodes, you need a load balancer there doing health checks to make sure it's not sending everything to a machine that's not there anymore. So the load balancer required when you're using Solr.net, which is what Sitecore uses for its Solr search provider as a .NET product. So when we're talking about our Sitecore indexes in Solr Cloud, I kind of wanted to talk about some of these terms and definitions because it can get kind of complicated, right? If you've been working with Sitecore, you probably know what an index is. Especially in Sitecore 7 with the search provider, indexing and searching became pretty easy. So you have all these configuration files with these index nodes in them, and they have information like the database and the index name and where the root node is and things like that. Sitecore ships with a few default indexes, one for each database. So we've got core, master, web. And then you may have some custom indexes for your actual site. So maybe you don't need to crawl all the templates and system items. You just want the content items under a certain node. So these would be your custom indexes. So the way these are represented in Solr Cloud is we have collections. So a best practice is to have one collection per index. And I'm gonna get into why later, why you want to do that, but it's considered best practice to have one collection per index. And we have right here, we've got this default config collection. So this is representing the default configuration that you generate out of Sitecore, that Sitecore's API uses when it queries these system indexes. So that's when you do things like search out of the content editor, right? It's querying these indexes. Then you may have custom configuration sets. So you may have another configuration set in Zookeeper that has some computed fields, like maybe you have some computed fields for your taxonomy for faceting, or maybe you have some sort of popularity index that gets run every night to go to some database to see how often something was clicked to give you most popular results. So you have another configuration set that has those computed fields in the schema, and that's different from the default one. So you have another config set in Zookeeper, right? These two collections are going to use that, and they correspond to these two indexes here. So if you've used Solr before, I just want to quickly mention, in a single instance of Solr, you're connecting to cores, and when you look at the configuration parameters in Sitecore, it's going to talk about cores. You can pass in the collection when you're using Solr Cloud. You can pass that in instead of the core. And I'm going to talk about the difference between a core and a collection. But as far as Sitecore is concerned, the way the provider is built, they're the same thing. So on the Solr side, this is how you would essentially, how the collection gets distributed into individual cores for high availability. So we've got our 3 Solr servers, and here we're going to use the Sitecore core index for an example. And when you create this thing, it's going to distribute replicas across each of the 3 nodes. So if I lose Solr server 2, I've still got these 2, oops, spoiler. I've still got these 2 nodes fulfilling requests. So we have what's called shards and replicas. So when you have a collection is composed of shards and replicas. And if you've worked with other database tools or search providers, you may be familiar with the concept of sharding. That's essentially cutting your index up into slices. And then a replica is a copy of a shard. So in this example here, we have only 1 shard in our collection, and we have 3 replicas. So we have 1 replica on each node. And you notice there's no, replica 1's not necessarily on Solr 1. When you create these things, it just sort of, uses the random number generator to figure out where they go. I don't know how Solr does it.
But when you tell Solr, make me a collection with 1 shard, 3 replicas on this set of servers, it just randomly distributes them in some order, and then elects a leader, seemingly at random. No idea how that works, but it works. So, the other thing to note is when you're creating your collections, you can actually specify what shard goes where, what replica goes where. So you have that ability, you have that fine control if you want it, but you don't necessarily need it to get started. So, if what I was just saying is confusing, and it was kind of confusing to me when I was trying to learn it, you can sort of keep these things in mind. A collection is essentially an index. It's one of your indexes in Sitecore. A collection is comprised of shards and replicas. So collection, 1 or more shards. Each shard is a slice of that collection, a distinct set of documents. Shards have 1 or more replicas, and each replica is a core in Solr. So if you've worked with Solr before, maybe single instance on your dev environment, just trying it out, you had to create a core for your index. So in Solr Cloud, each replica of a shard of a collection is an individual core. So I could probably show you what that would look like here. I'm going to have to drag some windows over. Okay. So this is the Solr admin. This is a Solr Cloud cluster I have running here at Velir. It's just on some VMs. I set it up just as sort of a sandbox to try to figure all this stuff out. So make friends with this interface if you're going to use it. I mean, there's a lot of stuff here. It's really going to help you. But if I go into the core admin, we're going to see here, I have a bunch of cores, right? And I don't know if you can read this. Let me try to zoom in a little bit here. So here's the name of my core, right? And we can see it's this automated scheme that, when I created this collection, Solr just generated the shards replicas for me, named them according to this scheme. This is shard 1, replica 1 on this server. So that's the individual, if you know what a Lucene folder looks like, it's got a bunch of files with funny extensions that, seemingly grow and shrink at random and then collapse into one file. If you look at the core folder in Solr, you're going to see that because it's Lucene under the hood. Now, if I go to this cloud node here, you can see these are my collections. And now because I zoomed in, it's a little hard to read. But if I refresh it, it'll expand out a little bit, yeah. So we can see here, Sitecore core index shard 1, and these are the individual replicas, and they're all reporting that they're in a good status, ready to work. And this black dot here denotes that it's the leader. There's actually a key down here. So if I were to take one of these nodes offline, we'd see that one go to this orange color, and that would mean that it's not available. And then if I did a bunch of stuff and brought the server back online, if you looked at this page, you'd see it's in this yellow color, it's recovering, and then it would get caught up and go to active. And that's when Zookeeper would say, hey, this one's ready, and the leader would start sending requests to it again. If I took 218 offline, Zookeeper would elect a new leader. This black dot would move to one of these other nodes, and it would happen instantly. So let's see if I can restart this PowerPoint from the slide I was just on. Hey, all right. So that's collections, shards, and replicas, and it's pretty important to have an understanding of what these things are if you're going to start working with Solr Cloud, because it can get really confusing. Just a quick note on sharding. I would say generally your Sitecore indexes don't grow large enough to warrant it. If they do, you're at a scale that is even beyond what I'm getting ready to deploy in a couple weeks with the client we're working with. So you can certainly support it, but I'm not going to be able to give you any sort of words of wisdom on that. You're going to be in uncharted waters, I think. I'm going to talk a little bit about sizing and memory requirements later, and we'll talk about when if you did need to shard, when you need to do it. So setting up Sitecore with Solr. If you've done this before, there's a great blog post out there by Dan Sulham. He kind of figured this out when it first shipped, and that's still the thing that I go to when I have to set this up on a new environment. The documentation from Sitecore is essentially a readme.txt with 4 lines in it of like 50 or less characters, so it's not super helpful. But the steps at a high level are this. You want to prep your Solr environment first. You want to get your whole Solr environment ready before you start connecting Sitecore to it. Because if you try to connect Sitecore to a Solr search provider that's not ready, it just starts throwing exceptions and is generally unhappy, and you can't do anything with Sitecore at that point. So the first thing you want to do is generate your schema for Solr. Sitecore ships with a tool that does this. Just show that real quick. It's on my browser here. So it's getting cropped a little bit on that screen. That's really obnoxious. I don't know why it's doing that. Okay. Don't you do it again. All right. So there's this is Sitecore 8.1. I actually went and got this whole thing working with Sitecore 8.1 like Monday. I was going to do this demo on 7.2 because that's what we were using with this client, but I was like, this is the Sitecore user group. You guys got to get the latest and greatest. So thankfully everything still works on 8.1. That would have been embarrassing. So you go to this generate Solr schema XML, and essentially you give it the source schema that you pull from the Solr zip file that you download from Apache. You grab the sample config, you take the schema, you pass it here, and then it puts in all the Sitecore stuff. Now, that doesn't work out of the box. You have to kind of tweak the schema that you get from Solr. Again, this stuff is all out there in blogs, and I have a link at the end of these slides with my blog. I've covered it there too. But let's just assume for the moment that this tool works without you having to muck with it. And it'll generate a new schema. And then you copy that into the configuration set and you push that up to Zookeeper. So back to this. So yeah, the next step is you upload that configuration to Zookeeper. And you have to give it a name. So there's a lot of different strategies here on how many configs you have. Does each index get its own config set, or do you kind of share it based on the purpose of the index? Does each database set of indexes share a config set? I mean, these are all things you'll discuss in the scope of a project, but generally, you can get away with the Sitecore default configuration that has all of your Sitecore fields that get generated. Then you take that and sort of remove all the stuff you're not going to use on your front-end search indexes, because that stuff's just going to bloat the index and slow it down. After you upload your configuration, you can safely create your collections in Solr. And again, it's one collection per Sitecore index is the best practice, so just stick with that. You use Solr's collections API to do that. And that stuff's all on the Apache wiki. You can just read the API, the create command, and pass in the correct arguments. After you do that, you want to set up Sitecore with Solr. So you have to do a little configuration in Sitecore. So when Sitecore ships, there's a bunch of leucine files in there. If any of these are still hanging around when you try to use Solr, Sitecore is going to blow up. And it's going to say something like, we can't find the default leucine provider or something. It's not going to tell you where the problem is. What I do is I look for all the files with leucine in the name that are .config, and I disable them. And then I do a search, a folder search in Notepad++ for leucine in the app config folder, and I make sure all that stuff's not included, and then we're pretty good. You go to the SDN or the dev.sitecore.net, depending on if you're on 7 or 8, you download the Solr support package, you install those DLLs and configs. And to use Solr, you have to have IOC. So if you're already using an IOC framework in your solution, chances are Sitecore will support it. They support like 5 or 6 of the pretty popular ones. We use AutoFac here. Sitecore supports it. Castle is pretty quick to set up. You don't even really have to do anything. You just drop in the DLLs and it works. So you can grab that off NuGet. When you try to run it, it's going to complain about the version. You can either do like the binding redirect or just get the old version off NuGet. You enable it in the global ASAX. That's one of the things on my wish list that I wish they would change, but for now you have to change from Sitecore web application. It's going to be like Sitecore Solr provider Castle application or something like that. So if you've done all that, and you've got all the configs in there, you've created your collections, you go into the default Solr config file and you tell it the host name or IP of your Solr servers, and you hit it, and everything should work. Cross your fingers. So this covers, setting up Sitecore with a single instance of Solr, but what about Solr Cloud? Turns out it's pretty much the same. Like I said before, you have to have a load balancer, but as far as the configurations go, it's exactly the same. Instead of pointing to a single Solr node, you point Sitecore to the load balancer. And it just starts distributing. You just do simple round robin, it'll distribute it amongst all of the nodes. So the reason this works is sort of just, I guess, kind of a happy accident, because I don't think they built the search provider with Solr Cloud in mind. But the way you query these things, the way you do selects and updates and things like that, and deletes and all that, it's the exact same API. It's just like Solr admin and then or Solr and then the collection name or the core name. You can do either one, it just figures it out. And then the command select, update, delete, and you pass in the parameters. So it all works exactly the same, fortunately. And like I said, you point Sitecore to the load balancer, and you want to configure your load balancer just to take those nodes out of rotation if they become unavailable. That's really the only thing you have to do. And you can use a simple health check for that, which can just be a query like, select like the top 0 documents. If you just get back an empty set of data, then you know your node's online. That's something we've set up. It's pretty simple. So just to talk a little bit about managing the configuration, because this is one of the big features I mentioned. You want to save it in Zookeeper. You can use the Solr admin to view the current config, and I'm gonna show you this. So I can find my browser here. That's not the right one. Okay, so here we are in the Solr admin again. Like I said, make friends with this thing. In this cloud node, we've got a lot of good stuff. We've got this tree, and this is going to show us what's in Zookeeper, which is pretty cool. So right here, we've got our config sets, and these are all the configurations I've uploaded. This is the one I'm using for this demo, so I can look in here and I can see all of this stuff. If I bring up my schema XML, whoa, look at that. I can just look at it right here in the admin. I don't have to go pull it out of Zookeeper or try to find it in SVN, or God help you if you're on SVN or Git or whatever. It's just right here. How do you know what config your collection's using? Well, you can check that too. I can go in here, I can click on that, oh, boom, config name. That's awesome. So this is really cool. So you can see kind of what's going on on your individual collections. You can look at the config it's using, and you can use that to figure out what's going on. So updates, when you update these configurations in Zookeeper, it automatically gets pushed out to every collection that's using it, which is great. You don't have to really do anything there. As soon as Zookeeper gets it, it pushes it out. You may have to reload the collection depending on the nature of the configuration update to make it take effect. That's something you can script out in PowerShell. I've actually done that. I'm going to share that with you guys at the end of this too. I've got a bunch of PowerShell scripts that make managing and administering Solr a lot easier. And when you're interfacing with Zookeeper, there's a client that actually ships with Solr. It's called the Zookeeper client.batch. And it has a bunch of commands for interfacing with Zookeeper, but the most important ones are up config and down config. So I have a quick little demo of that too, if you want to see it. So let me show you how this works. Let me bring up a command prompt here. Drag it over there. Oh, that's really small. Can I zoom in on this? Oh, you'll just have to pretend you can see this. So you may or may not be able to see this, but essentially I'm calling the Zookeeper client batch. I'm passing in a bunch of parameters like where Zookeeper is, the IP address, the command, up config, the directory of the configuration I want to upload. I can just show you that. So this is all the stuff I'm going to push into Zookeeper. It's just in this folder. If I hit enter, a bunch of stuff flies by as it's uploading everything to Zookeeper, and then it's done. I can do the same thing to pull that down. All you do is you switch up config to down config. It's the exact same arguments. And once again, I've got this stuff on my blog. I'll throw up a slide at the end with a link to it. But this stuff is on my blog. I also have some PowerShell scripts to help you with that. The important thing, the reason I'm bringing up the PowerShell scripts is that you want to, if you've got a CI/CD process and you got to fold Solr into it, you don't want to make those steps manual. So you want to have these scripts be able to do that. So you use these tools, you invoke them from PowerShell. It can pull the stuff out of your Jenkins workspace or whatever, push it up to Zookeeper, take care of everything for you. It's great. Managing your Solr collections, you want to use the Collections API. If you've worked with Solr before, you've probably done stuff with the Core API. When you're working with Solr Cloud, you want to use the Collections API because remember, cores and collections are different. So if you work on just one core, it's not going to affect the other replicas in that collection, and you may have some funky results. I don't know. No warranty if you do that. When you create your collection, you have to specify the configuration upon creation. This is actually something I haven't figured out how to do if it's possible. Like if I create a collection, I want to switch it to a new config set. I'm not sure if you can do that. So plan ahead. Again, that's one of those things you might discuss on your projects. Just how many config sets do we need? Shards and replicas, they can be created up front, or you can add them later. So if you're doing sharding, or you bring another node online later because you've got that much search load, you have to add another server to the cloud. You can spin up replicas of all your collections on that using the API. So you can add things later. Zookeeper will sync them all up again. And like I said before, one collection per Sitecore index is best practice. And I'm finally gonna tell you why, because I've got my notes here to talk about it. So I mentioned before, you have the option to tailor your configuration to that specific index. That's important when you're talking about your content delivery or your client-facing indexes that your end users are going to use. You want to sort of get all the cruft out of them, pare down the document sizes, and just sort of make them operate much faster. You can tune and monitor the caches more closely. If you've got all your indexes crammed into one collection, they're all competing for the same cache space. So if you've got a really popular index, that's going to dominate the cache, and when it goes to one of these less popular ones, like say it's an author index, it's not going to get a lot of cache hits. So by having a separate collection for each one, it gets its own dedicated cache. And you can tune those at the index level. So if your main search index, you want to give that a bigger cache, it can have its own config set, you can do that. If you want to give your author index a much smaller one, you can do that too. So like I said, smaller collections can search a little faster than a huge one because you get fewer parameters. The biggest reason you want to do this, though, is to support what's called switch on rebuild. So if you've used Solr before, you may be familiar with the switch on rebuild strategy in Sitecore. So I'm going to give you a little disclaimer. This thing doesn't work with Solr Cloud out of the box. That's one of the big deficiencies. You'll have to go to Sitecore support and say, I'm using Sitecore 8.1 with AutoFac as my IOC, and I got Solr Cloud. You need to give me the switch on rebuild hotfix. And hopefully they can get that out to you in a couple days. We have that on the project I mentioned. Sitecore built us a couple patches and a hotfix to sort of fix switch on rebuild. And what that does is it maintains querying availability while you rebuild the index. So if you know how Sitecore does its indexing, when you do a rebuild, it doesn't delete, just wipes everything out. Then it starts adding the documents back in one at a time. So if it wipes everything out, you can't query that index. So what the switch on rebuild strategy will do is it keeps a copy of the index. When you issue a rebuild command, it starts rebuilding the copy that's not being used, and when it's done, it swaps them. So now it's using the one it just built, and that other one is sitting there waiting to be rebuilt, and just sort of does kind of a round robin like that. And Leanne, like I said before, make friends with that Solr admin tool. I'm just going to show you a couple, real briefly, just a couple other things in there. If I can get find the correct browser tab here. There it is. Really important one is this core admin. Like I said here, this kind of gives you an overview of it. We can go to the core selector, and this isn't the greatest UI, but you can fortunately search, like I can do Sitecore master, and oh, there it is, great. So there's a lot of good stuff in here, right? You can do like analysis, you can actually query the index, which is great. So the nice thing about this is you can kind of test your queries. When you're using Sitecore, it has that search log, and it prints all the queries in there when you search with Solr. So if you're debugging, you can go in there and see exactly what query it ran at Solr. Come in here, and you see how Solr gave you this URL? So if I click that, here's the actual response, and like I can just start tinkering with it in here to try to figure out what I want to see. So that's a really important tool, and we've gotten a lot of mileage out of that. For Solr Cloud specifically, what you want to look at is this stats page, and this is going to talk about your caches. This is good for Solr too, but especially for Solr Cloud. This is going to talk about your hit ratio, right? So how many of these things are going to cache? How many of these things are going back to the index? Obviously, pulling out of cache is going to be a lot better. So I'm getting about 60% of my documents are in the cache, right? And it's going to tell you inserts and eviction. I haven't used this index much, so it hasn't evicted everything. Everything I've looked up is just stuffed into cache and referenced it again. We've got our field cache, our field value cache. What these things mean, I don't have enough time to get into them, but I'm happy to talk about it after. And I've got another blog post and draft on my blog kind of talking about how to read this stuff and figure out what it means and how to tune it. So that's a lot of information, and I've got a bunch more slides, but I want to sort of take a break and see if anyone has any questions on what we talked about so far. Because if I start going into the next stuff and this stuff is sort of confusing, you may totally zone out, so. All right, great. You're a really smart audience. Oh, what's up?
How big your data set has to be that you see significant gain
So it's not necessarily the size of your data set. It's more the size of your whole operation. For the reasons I mentioned before, if you have a distributed architecture, when you start adding more and more front ends, you've got these copies of these indexes everywhere, and if you've got 30 pieces of content, maybe you're okay with the CPU spiking for half a second every time you publish. Some of the clients we've worked with, they've got 10,000, 100,000, million content items, right? The client I mentioned before we're going to production with in Solr Cloud, they have, I don't even know, they've got hundreds of collections, right? So they've got so many different indexes. These collections, each one of them has in them on the order of 200,000 documents, right? So Lucene was a really big pain point for them because they've got sites in production, they're doing rapid content entry, content maintenance, so high availability for content entry was a huge thing for them. Because if CM goes offline, they can't produce content, their entire workflow stops. It's like a whole train that comes crashing to a halt. And when they would publish, their front-end servers would become unresponsive. And when they publish their site, it takes a long time. And that whole time, the servers are sluggish. So Solr Cloud was really kind of a no-brainer for them. But this is the sort of thing you got to kind of evaluate in your project. I don't think Sitecore is officially making this recommendation, but I've heard rumors that they're going to kind of suggest maybe in 8.2 that if you've got a distributed architecture, you want to consider centralized indexing, getting off Lucene. It's just going to be considered a best practice, especially now. Let me find my browser here again. I don't know if you've noticed in here, this is on 8.1. Look at all these indexes that Sitecore just ships with. It's not just core, master, and web anymore. We've got the Federated Experience Manager Index. We've got the Marketing Asset Index, Marketing Definitions, Social Messages Index. There's a lot of stuff going on. right? And this stuff's churning as the analytics, the XDB analytics database is doing its thing. If this is all running on your front end, that's CPU cycles, resources being consumed. If it's happening on Solr, it's happening on some other server that's not serving content, you don't have to worry about it. So, unfortunately, like I said, there's no clean answer. It's just sort of, you got to kind of go with your instincts.
So a collection is just a new notion that the Solr and Cloud works with instead of anything?
Yeah, so if you want to think of it this way, your collections should be one-to-one to your Sitecore indexes. So for every Sitecore index, make a collection in Solr to represent it. And the reason I was talking about cores and collections is if you've worked with Solr before, which I went to production with just a single instance of Solr on a couple projects. I got really confused, like what's a core, what's a collection? It's not super clear in Apache's documentation, and I kind of had to figure it out. So that's why I'm sort of explaining it. But if you're just going straight into Solr Cloud, just think a collection is an index in Solr Cloud. Just think of it that way, and you'll be in good shape. Any other questions before we move on?
Do you have Zookeeper running on the same as other servers?
Yeah, I was just about to get to that. So the recommended best practice is the Zookeeper ensemble is its own cluster, and then your Solr servers are on their own servers. That's really overkill. You can have Zookeeper running on its own drive. So let's say you've got a server, you maybe put Zookeeper on your C drive with your OS, because once Zookeeper starts off, it's really sort of low maintenance. It doesn't consume a lot. You put Solr on your D drive. It may be if you've got some recovery volume where you're backing up your indexes, that would be like your E drive, for example. But yeah, Zookeeper, Solr on the same machine, for sure. All right, cool. So next thing I want to talk about is just sort of optimizing Solr Cloud for Sitecore. So, this is great, what I just talked about. This gets you the works on my machine stamp. Your local environment works great, QA environment's great. Taking it to production is scary, because now we're going to throw thousands, hundreds of thousands, million users at it, right? And it's Java, it's Apache, like this isn't .NET, it's scary stuff. What do I do? How do I find out what to do? I don't know how any of this works. So I'm going to tell you some of the stuff I learned, and hopefully it'll help you out. And like anything in life, it's always better to plan up front if you can. And then when that plan, goes wrong, you're at least prepared mentally to handle it, because you're like, I tried to plan. So first of all, the server architecture. So this is sort of kind of talking about what you just asked. When we talk about a cloud, right? This is how I picture servers in the cloud. They're just sort of out there, sort of existing. So Solr is very memory intensive and disk intensive, but it's relatively light on the CPU. So like I said, Zookeeper can exist on the same machine primarily for that reason, because Zookeeper tends to use more CPU than these other resources. And once Zookeeper starts up and gets everything up and running, unless something goes wrong, it's relatively, idle, which is good. For your disks, you want to have high IOPS, which is like input-output operations. So preferably at the database level. I was talking to some couple Solr experts about this, and they're just like, the more the better. As much as you can throw at it, just take it. But generally, if you look at like the level, if you're talking to your hosting provider or whatever they give you for like a SQL server, you'll be good with that on Solr as far as the disk operations. The ratio of CPU to RAM. One CPU core per 8 gigabytes of RAM is generally a good ratio. So if you get a 32 gig RAM machine, you only really need 4 cores. You don't need 8. So if you can configure it that way, maybe save a few dollars. It'll help you out. And the individual servers, you want them to be kind of near each other on like the same subnet, the same location. You don't want to put one node of your cloud in Bermuda and another one in New York and another one in Shanghai. That's not really going to help you out. Because the reason for this is Solr syncs the collections via log shipping, so it ships the transaction logs. If you've done master-slave replication, it takes snapshots, and that you can kind of distribute a little more because it downloads the snapshots, and the slave is not meant to be the same sort of high availability model. But with Solr Cloud, you want everything to happen in as quickly as possible and kind of simulate real time. So having them all kind of next to each other makes that happen. The memory settings, you see this giant pile of RAM, like that's what you want. So when we talk about memory with Solr, because it's a Java app, it's got to run in a JVM. And it uses that for its heap memory, essentially, so all of just, the stuff that the Java code is doing. So a good starting point is, 25% of your available memory, dedicate that to the JVM. And I believe in the newer builds of Solr, that's when you start it up with, if you don't tell it otherwise, that's what it does. In older builds, it would basically, I think it used like 100 megabytes, which is ridiculous. If you went to production with that, you'd be getting a call like within an hour. So on like 32 gigabyte machine, you give 8 gigabytes to the JVM, leave the rest for the disk cache. So the disk cache is what Solr uses. It's going to consume whatever's left. Whatever the OS isn't using, Solr is going to use the rest of it when it needs it. That's what the query cache, the filter cache, those things I showed a little while ago. As queries run, it's going to start filling those caches. And it's smart enough to actually figure out, hey, these are the popular queries. This is the stuff we're going to get preference to in cache, as opposed to these things that don't get searched for very often. So there was some study out there that I read that showed that like 90% of search results are people searching for the same thing. So Solr is going to cache that stuff for you, and for 90% of your users, search is going to be quick. For the rest of them, it's going to be maybe a little slower. So when you're monitoring these things, if your indexes start to grow larger than 50% of your server's memory, that's when you want to maybe consider either removing some fields to get those index sizes down, maybe omitting some documents from your crawler, like maybe you're crawling a bunch of archive stuff that just never gets searched for, you don't need. Or maybe you want to consider a sharding strategy. Because if your indexes start getting bigger than the amount of RAM you have, then you're going to be doing a lot of paging and everything is going to start to slow down all of the sudden, and it's going to be a big problem. So you want to try to stay ahead of that. I think we've actually seen that on some of our Solr applications, like just the size of the index starts to outgrow the amount of available memory, and all of a sudden it's just like, boom, search isn't working, help. And it was just pretty slow. So a Sitecore specific customization you can do, I talked about centralized indexing, and to take advantage of that, you want to have a dedicated indexing server. And hopefully you can read this diagram here. Made this with my pro Visio skills, almost as pro as my PowerPoint skills. So what we've got here, we've got our nice Solr Cloud. I didn't really use the cloud graphic because it didn't fit, but we got our Solr machines here. We've got our 2 CM servers. We've got our 2 CD servers, or however many you have. So these are essentially read-only from Solr. They're querying, they're not indexing. What's happening is we've got this job server up here that is, set up to watch the event queue and handle all of the indexing operations. If you've been using some of the newer versions of Sitecore, you may already be doing this with publishing. You may have a publishing server that when you kick off a publish, that gets jobbed off to another machine so it doesn't bog down your CM. You can do the same thing with indexing. So this is actually new in 8.1. This was on my wish list, and then I scratched it off when I set this up on Monday. We have the publish end async single instance strategy. And I'd like to think that they implemented this based on the project I mentioned that we're going to production with, because we specifically demanded this from support. Now it's in 8.1, pretty cool. So you just give it the job server name, and you don't have to do anything with your configurations. Otherwise, you're going to want to set the manual indexing strategy on all these servers, and then on your job server, do your master async, publish end async, whatever the defaults are for the particular database. And that'll really let you take advantage of centralized indexing. Otherwise, if you don't do this, you get the same problem every time an indexing event happens. Every server's processing it, and it's totally redundant. So this is something you really need to do on production. Local dev environment, maybe you don't have to worry about it, but optimizing your schema. That was the other point of feedback I got, was more memes. So there's some memes here for you. So like I said, you can remove unneeded fields to boost query performance. Like almost the low-hanging fruit is when you generate that schema XML, you're going to see every field on the standard templates in that schema, and you're almost never searching those in your front-end app. Like nobody's searching for is clone, for example, right? Like we don't care. So you can get rid of all that stuff. You can prune it, and that's going to not only bring down the size of your index, but it's fewer fields it has to crawl when you just do a query, when you just do like a general text search. And then you can fine tune your field types and analyzers, and this is really nitty-gritty Solr. You could probably do a whole series of talks on just field types and analyzers, but your stop words, your synonyms, your relevancy, all this stuff's configurable. It all kind of follows a factory model. So you put in your analyzer and it kind of steps through them and does its transformations and things like that. If you really dig into the schema XML, you'll see all this stuff. Near real-time indexing, this is one of these optional things. What this means is that when a document is indexed, it's immediately available for search. So just to understand why this is necessary, Solr has two kinds of commits. You have a hard commit, which is a write to disk, and a soft commit, which is a write to memory. So if Solr commits to memory, you can search for that document in memory if a search comes in. And writing to memory is a lot cheaper than writing to disk. So if you set up near real-time indexing, it's off by default, but it's very easy to turn on. You can write to memory like every second, and then maybe write to disk every 5 seconds. This also helps avoid race conditions on CD. Like if an indexing event comes through on a publish, and a page request comes in right after that, there's a chance that the index hasn't picked up that change yet, and then you've cached the HTML until you publish again, you've got stale results. So this will help avoid that. And this is configured in the Solr config XML right in that configuration folder you pushed up to Zookeeper. If you Google this, Solr near real-time indexing, you'll get the Apache wiki page, tells you exactly how to do it. Monitoring. I think this meme kind of says it all. You don't want to be this kid. You want to be kind of a good citizen so that your ops people like you. You can monitor the health of your nodes with a simple query, like I mentioned before. You're going to need that for your load balancer. You can configure core level health checks if you want to get really crazy. So you can know when an individual core goes offline or falls behind or becomes unavailable and do something with your query distribution. I haven't done that, but you can certainly do it if you have the time and energy to dig into that. If you're using an APM tool like New Relic or Dynatrace, AppDynamics, I mean, they all have plugins for Solr that gives you a lot of good information right out of the box. You just install it and you're good to go. Beyond that, if you are good with Java, it supports the JMX protocol, and you can use that to pull like pretty much anything out of Solr that you want. There's a ton of open source projects out there that do exactly that. So finally is my wish list. So the reason I'm including this here is because we're all like Sitecore partners or clients here. And if you start using Solr Cloud and you go to Sitecore support and say, hey, I need this, and they start hearing it from more and more people, they just may implement it, and then we don't have to worry about this custom stuff anymore. So the biggest thing on there is switch on rebuild support. If we have to rebuild our index, we don't want it to become unavailable for querying. That's just, really, it's no good for anybody. We need to support that. This one right here, because of the way it does IOC, if Solr's misconfigured or whatever, the whole app is dead. It just, it won't tell you anything. It's not ideal. So if your whole cloud went offline, Sitecore would die. That's a big problem with individual Solr right now. If your Solr server goes offline, so does your app. It's not just like you lose search. That's just because of the way they configured IOC. We got a patch for this from support too, but it had to be tailored to the IOC provider that we were using. Better error messaging around when Solr is misconfigured. Right now, when Solr is misconfigured, it just says it's unavailable. It doesn't tell you what the problem is, and you're digging through tons of stuff. It got a little better in 8.1. It at least tells you what collection it's having, what index rather it's having the problem with. But if you fix that one, move on to the next one, it'll tell you that one again. So 8.1 started to address this, but it doesn't tell you, hey, your scheme is bad, or you have, I can't reach the URL or, this index, it just says it's not available and you got to try to figure out why. So it's not great. It could be a lot better. Fix the schema XML generator, or at least document it. Tell us what it's doing, why it's doing it, so the community, developer can at least figure out why it doesn't work. Because if you download from Solr, the schema from Solr right now and put it into that thing, it's just going to throw an error and you have no idea why until you start reading blog posts. The last thing is just to remove these. Every time a Sitecore does a commit, it calls optimize. You don't need to do that anymore in Solr 5. It automatically optimizes, so it's really just a bunch of wasted effort. They can just take that out. It'd be great. So the reason for this wish list, the Solr search provider was built against Solr 4.1. Solr is up to 5.4 now, so it's been through like a major release, and they're releasing a point release like every month or two at this point. It's pretty rapid. Like I said, IBM is actively working on it, so there's a lot of stuff happening. And Sitecore just hasn't kept up with it. And if they're going to start recommending Solr for your analytics indexes, they have to kind of, shore up their provider, in my opinion. So just the key points. If you take anything from the talk, take this stuff. Use centralized indexing with the distributed Sitecore architecture. It's just as you start to scale out, it'll pay more and more dividends. If you use Solr Cloud, you want a minimum of 3 servers, and that's so we can resolve conflicts and have a quorum. You need a load balancer to distribute the queries from Sitecore to Solr, again, because of that gap in the Solr.net DLL. Or you can go fix Solr.net if you're feeling like adventurous. You go fix that. Then rewrite the search provider to take advantage of it. It's another option, I guess. 1 collection per Sitecore index. Just make those indexed collections, make those 1-to-1. In 8.1, we'll actually enforce that out of the box. In prior builds, everything just went into the collection item buckets. Now the default is the name of the index is the name of the collection. So they're actually enforcing that out of the box in 8.1, but you can still override it. And finally, just keep in mind, switch on rebuilds not supported, but you can get the hot fixes from Sitecore. You just got to ask for them and give them time to build it for you. Because it's not a patch, it's a hot fix. They got to rebuild like the Sitecore kernel DLL specifically for you. So it's not great, but it's available. So I guess I'll take some questions. And I talked about some tools in this talk, those PowerShell scripts. I didn't really have time to demo them, but I threw them up on GitHub if you want them. I'm going to put them up on my blog too, just a link to that, maybe some other useful posts that I found. So keep an eye out for that. Maybe go from like 2 visitors a day to like 20, however many are in this room. That'd be cool. Any questions? Yes?
How do you pronounce your Twitter handle?
It's Wallapuktis, and don't ask what it means, doesn't mean anything. It's a nonsense word. It's been following me since like the internet started when I was like 12 years old. Anyone? No? All right. Well, thank you. Appreciate you coming out. Hopefully you learned something.